Welcome back to another video of Turtles All the Way Down. Black holes conjure up some of our greatest imaginations. These are places in our universe where even the laws of physics seem to go haywire. Very strange phenomena take place around and within them. What exactly are black holes? That's what we'll be discussing in this video of Turtles All the Way Down. Come with me as we dive into these mysterious objects. Now, all stars are formed from spread out gas and dust in space called nebulae. Some parts of these nebulae will begin contracting and squashing together due to slightly more gravity in those regions. This collapse continues and attracts more gas and dust to collect there from the ever-increasing gravitational pull from the expanding matter. This eventually leads to a gigantic ball of gas that becomes so heavy gravitationally that the squeezing pressures within heats up to nuclear fusion level temperatures. That is about 15 million degrees Celsius. When this lights up, a star is born. The great expanding heat within the star prevents the star from continuing to collapse in on itself. A star's entire life is a beautiful balancing act between its heavy inward gravity and its outward expansive heat and energy. If one were to give, the other will dominate. The beginning amount of dust and gas in that nebula, where the star formed, determines how massive the star becomes. Some begin with just enough kindling to start the star shining and no more. Others have so much matter that the resultant star becomes very massive and very bright. As a result, there is a wide variety of masses of stars in the universe. Most stars are those that are smaller than our sun. Very, very few are more massive. Each leads to a different life, but they all eventually succumb to a stellar death. The more massive the star, the faster it will burn out all of its mass, and the shorter its life is. The smaller stars can live out a life of trillions of years. Our own sun is about halfway through its 10 billion year life cycle. However, larger stars can only last a few million years before they die. The death cinders of stars vary depending on their masses. The smaller ones slowly burn out to become brown dwarfs. Larger ones, such as the sun, will puff up to become red giants, then eventually shed its outer layers and leave behind its glowing hot core called a white dwarf. Still others that are larger will eventually run out of their fuels and then collapse and crush their cores, then explode in an extremely brilliant event called a supernova. The end becomes a shrunken and extremely dense core called a neutron star or a pulsar. A tiny percentage of even more massive stars go further than this. Nothing can prevent their entirety to collapse into nothing, to a point called a singularity. This is a black hole. How much mass must a star have to become a black hole? It needs to contain at least 20 times the mass of our sun to collapse into a black hole. Our sun has what is called one solar mass. Any star with 20 solar masses or more will eventually become a black hole when its fuel burns out. Black holes come in a wide range of masses, from 3 solar masses to the supermassive ones that can be many billions of solar masses at the centers of galaxies. Okay, so what happens around a black hole, and why are they so mysterious? Black holes are very interesting in that the mass of an entire star or more is concentrated within an infinitesimally small point. This makes the surrounding gravity nearby so intense that anything coming close to it will eventually be pulled in and be lost forever. This includes light. This means that no light from within can ever be emitted, and this is what gives it its name. The spherical region around the black hole where nothing can escape is called the event horizon. Many black holes, such as the supermassive ones at the centers of galaxies, have an enormous amount of gas and material circling around them outside of the event horizon, mainly coming from stripped nearby stars. This lights up to enormous energies. These have recently been imaged. All of that matter soon gets pulled into the black hole and adds to its mass, making it stronger. At the very center of the black hole, called the Singularity, our most accurate and precise laws of gravity, which are Einstein's general theory of relativity, break down. This is because we are dealing with pressures, gravities, and densities that approach infinity. Infinities are nasty mathematical objects that physics cannot traditionally deal with. Remember the old algebra rules where you cannot divide by zero? Why? Because it becomes infinity. We like to stay away from those. Black holes spin and may contain electrical charge. So they really only contain 3 observable properties: spin, charge, and mass. The physicist Stephen Hawking pioneered important theoretical work on black holes. He applied our other most precise and accurate description of nature, quantum mechanics, to black holes. What he discovered is that black holes really aren't devoid of light after all. There is a minuscule energetic glow that surrounds black holes, now called Hawking radiation. This energy consists of a continuous production of subatomic particles right at the edge of the event horizon. Hawking radiation eats away at the mass of the black hole, eventually causing it, many trillions of years in the future, to be destroyed. There has been fascinating scientific speculation about the infalling matter approaching the Singularity and its inevitable demise. What would an astronaut experience if she approached one? This all depends on if the black hole is a spinning and/or charged one. I'll focus on the simplest, a non-spinning and non-charged one. Outside of the event horizon, she would begin feeling a larger and larger difference in heaviness on her body. Her legs would feel much heavier than her head. Still outside of the event horizon and looking out to the rest of the cosmos, as she approaches and eventually crosses the event horizon, she would see the entire view of the universe curl up into a smaller and smaller circle that will eventually be bluer. It then becomes a point and flashes out of existence at the moment she hits the Singularity. She will experience time no differently than she has always experienced it. Along this entire trajectory, she would also be experiencing a weird phenomenon called spaghettification. Her entire body will be pulled and stretched into a longer and longer line toward the Singularity, like a long strand of spaghetti. Her fellow astronauts, staying on the starship safely outside of the event horizon, observe something very different. As she approaches the event horizon, they see her approach at a slower and slower speed. From their perspective, they see her surrounding time as slowing down to zero as she gets to the horizon. To them, she never crosses the event horizon. Time stops there to the outside observers. This phenomenon is called time dilation. You may ask what happens then in the case of a spinning and charged black hole. This is where speculation runs rampant in black hole physics. There is no consensus in the scientific community. It may be that at the Singularity there is a tunnel through space-time called a wormhole. Where it leads is anyone's guess. It would most likely not be able to stay open indefinitely without some kind of help. Experiences of time within a spinning black hole may also be very strange as well. Many stories and novels and movies have been made concerning traversing black holes, and exiting into other universes, other parts of our universe, or in other times. Until physicists have a theory that can successfully unite the two greatest physics theories of nature that we have, the general theory of relativity and quantum mechanics, a so-called theory of everything, we will not know the answers to these questions. Black holes are some of the strangest and most extreme objects in our known universe. They stretch our imaginations, and the most exciting thing about them is that they are very real things. Thank you for watching another video of Turtles All the Way Down. Please subscribe to the channel and help me grow and share these fascinating questions. Until next time, stay with us by avoiding those crazy event horizons. Bye for now.